Okay, welcome to another recap video for the P1 paper. If you've not watched the previous video, the first 7 chapters were covered there. There's chapter number 8, trigonometry. It starts off with a build up on O-level trigonometry where you study basic trigonometric ratios. The cosine rule and sine rule also come up, but they come up in the next chapter, which is circular measure. That's basic trigonometry that you need to know. Then the first thing that you need to know for A-level trigonometry is conversion from degrees to radians. Pi radians is equals to 180 degrees. Now sometimes you have pi, sometimes you don't have pi. You can have numbers instead. 3.142 radians should equal 180 degrees, or could be anything else, 1.2 radians, 2.9 radians, whatever the question might give you. So you need to be aware that radians can also appear in decimal numbers. The first thing that I teach when I'm teaching trigonometry is graphs of trigonometric functions. So we sketch these graphs. Again, I generally teach these values using a table, using the table function on your calculator. If you don't know how to do that, please go back and watch the video on my channel. That will help you construct a table using those values. It's useful because that table function helps you make any graph that you want. So this table that you see here was actually made using a calculator, and the values were then plotted on an axis, and that should give you the sketch of the graph. Then this is about interpretations of different things. These questions have come up more often in the recent past papers, and one of the reasons is that um, the topic of transformation sort of combines with this idea. So you see there are three transformations happening. One is bx, so it's a horizontal transformation. You will either shrink or expand the graph. There is a vertical transformation which says a, so that causes a stretching on the vertical axis, and there's c, which causes a translation on the vertical axis. All of these three have an interpretation in trigonometry. One is called the amplitude, the other is tells you the number of cycles, and c represents the false axis. Sometimes these numbers are unknown, so these interpretations sort of help you calculate the unknowns. This max and min is can be the other way around as well. The minimum can be c minus a and the maximum can be c plus a, depending on what the equation of the function is. So please be aware of that. I generally encourage my students to use a calculator to find out the range, which is maximum minus minimum maximum and minimum values. You can do that with a calculator too. Okay, moving on, there are questions on graphs that asks you for the maximum points and minimum points. Again, all of these were done with a calculator. Questions with unknowns where a and b are positive constants, so there we use the idea of the interpretations that we talked about above. That should help you solve the questions. This is again a past paper question. If you haven't done these before, please do them now. They're useful in understanding the topic. That is another question. Although I haven't solved this, I would encourage you to solve this. It has come up more often in the recent past papers, and you need to be aware of these ideas as well. Then this is sort of an example that combines, example number 10 combines the idea of how transformations can be used. So that's something that you need to be aware of. So this is just a horizontal stretch with a factor 1/3. This is a translation 3 units up. That's 60 degrees to the right. And that's a vertical stretch with a factor of 2. And all of these questions are there that we've done in class. I do them in the lecture videos as well. This is a graph for tan x. Tan x is unusual in the sense that it's not it goes to infinity, which means that it's not continuous. It breaks at 90 degrees, it breaks at 270 degrees, it becomes undefined. Also important, where you should know where the curve becomes undefined, because this undefined line can move left to right depending on if there is a stretching or a translation on the horizontal axis involved. All of these ideas are now relevant because the topic transformation of functions has become relevant. So again, some questions solved here. Okay, then we go on to what we call trigonometric equations. Now I have a particular way of solving trigonometric equations. You must have done it differently, or you must have done it in the same way. I go on in detail and I try to get my students to learn the steps. So those are the steps that are there. you first mark your quadrants if you are solving trigonometric equation like that. When I say mark your quadrants, it means that you have to point out what quadrants you think your answer should lie in based on the positive or negative sign of this number. So if sign is positive, it lies in the first and second quadrants. Then you go on and calculate alpha. Alpha is a basic angle, and all those rules are there. Then we have rules for quadrants, and those that give you the final answer. If you don't know this entire process, it's very necessary, absolutely necessary to know this process, because without this, you will not be able to do most of the questions. Then again, lots of questions in this. You can also come across negative cycles. So that's something that bothers a lot of people. So what I do is I teach the negative cycle separately from the positive cycle. I don't connect the two. So you see negative quadrant 1, negative quadrant 2, negative quadrant 3, and negative quadrant 4. That has nothing to do with the positive cycle. So that's my negative cycle. Those are my rules for the negative cycle. This comes up rarely. So what I tell my students is that when you're going into the exam on the last day, just rote learn these and then go into the exam. In case it comes up, you just need to sort of explore the idea. And to be honest, even if you were to mess up this idea, you wouldn't get a lot of marks subtracted, as long as your positive cycle calculations and your basic ideas of trigonometric equations are clear. Okay, another question on negative cycles. Then I come up with different trigonometric equations where you have to first solve a little and then do that. Then you can have differing angles as well, 2 theta. Again, lots of people have lots of different ways of doing this, or some people will go on and change the cycle. What I generally tell my students is that when you have 2 theta, what it simply means is that you have to go around this quadrant system twice. So that's quadrant 2, 1, 2, 3, 4, and then 5, 6, 7, 8. All the other things remain the same. How do you go from quadrant 2 to quadrant 6? You add your answer from quadrant 2 to 360 degrees to get to quadrant 6. Why? Because quadrant 6 is 4 quadrants ahead of quadrant 2, which means it's 360 degrees ahead of quadrant 2. You can see my calculations here. The black calculations are done right at the end when you've come up with all the quadrants first, and then you sort of try to find theta by dividing 2 on the other side. Then you can have quadratic equations within trigonometry. Sometimes the question will ask you to express it as a quadratic equation in tan theta or cos theta or sin theta, whatever the question might be. Again, you solve it like a normal quadratic equation. Some people have the question, do I need to show the quadratic formula? It's always safe to show the quadratic formula, because you don't know if the examiner has put a method mark in the marking scheme. So it's always safe to put in the quadratic formula. Then you have trigonometric identities. So for trigonometric identities, you need to know your identities. Tan theta is basically sin theta over cos theta, and sin square theta plus cos square theta should equal 1. Sin square theta is therefore 1 minus cos square theta, and cos square theta is 1 minus sin square theta. Those are the variations of the second identity. Again, this is a common confusion, although this question is just about simplification. There is a common confusion as to what side you should start on. Remember that you can start from whichever side you want. I generally tend to start from the side where I can possibly sort of apply an identity. Okay, so if I'm on the right hand side, I don't see any identity that I can apply. Tan theta is sin theta over cos theta, so that's something that I can apply on the left hand side. Again, I will start on this side from on this question. Why? Because I can apply the identities there. So lots of identities. Stop and try whichever identity you want, and you should be able to see the solution as well. Then you can use the identities to solve trigonometric equations as well. Trigonometric equations can have all of these identities there. So any identity that has any equation that has both sine and cos should turn into a tan equation. So you see this turning into tan, and then I follow the normal step of solving an equation. So this question, for example, has 2 sine square theta equals to cos theta plus 1. So you need to apply an identity for sine square theta. in order for this equation to have one consistent trigonometric ratio. So remember that you cannot solve with multiple trigonometric ratios in the same equation, although there is this possibility as well that you might have two different trigonometric ratios, but then a certain process of factorization will happen before you can solve it. For example, in this question, take a common, you have two different trigonometric ratios, and then you sort of solve it. Pause here and do this question if you haven't done this already. Then lots of past paper questions, some about identities, some about equations. Okay, then you have this question, that question. Lots of questions from past papers. You see negative range here, so follow those negative rules if this comes up. Again, you see your all 3 marks would not be dependent on you knowing the negative range, so keep that as the last thing in your head. Most questions will have positive ranges, but some will have negative ranges as well. Some questions will be just in radians, so you need to switch your calculator to radians depending on the question. Then this is another type of question that comes up in trigonometry, and you need to be able to understand what this question does. Okay, so now the first thing that I notice in this question is that it says reflex angle theta, so I need to know what angles are called. There are acute angles that are less than 90, greater than 0. There are obtuse angles that are between 90 and 180, and all angles that are greater than 180 but less than 360 are called reflex angles. So with reflex angle, I know that it lies in the second, in the third or the fourth quadrant, and it says cos theta equals to k, where k is a positive number. So I'm absolutely sure that I'm talking about the fourth quadrant now, because cos theta is only positive in the fourth quadrant. Then there are various ways of doing this question as well. I generally explore the idea of using identities to solve for the missing trigonometric ratio. So if I'm given cos theta, I can use this identity, plug in sine square theta plus cos square theta equals to 1, and sort of replace cos theta with k, and then sort of solve the identity to obtain the other trigonometric ratios. Multiple questions on this. You can look at this question as well. Pause here and sort of try to do the question if you haven't done this already. Then trigonometry also combines with functions. That's a very predominant topic in the recent past papers as well, where you have functions and trigonometries coming together. Again, the concept of inverse functions, whether the inverse exists or not, and the concept of domain and range is also very relevant. So you should know all those ideas when you are doing trigonometry and functions together. You can pause wherever you want and sort of do the questions. Then that's the end of trigonometry. Then we go on to the chapter on circular measure. So when you are doing circular measure, again, a lot of O-level ideas that are there are sine rule and cosine rule. Those two things that you need to be aware of. When do you use the cosine rule and when do you use the sine rule? Those are all ideas that are assumed as part of your understanding. Area for using trigonometry is also assumed in your understanding. You can have questions that don't even involve circles at all. Those are just about trigonometry, and these questions are sometimes challenging. Stop and do whichever question you want. But a large part of this chapter is about sectors and segments and circles and so on. So you have these two formulas, one for arc length and the other for area of sector. These questions are mostly about your basic understanding of applying formulas, and then doing a lot of algebra, to be honest, and a bit of mensuration as well that you do in O-level math, where you try to find the shaded areas in different cases. So those are questions. You can go over the questions. I do a lot of questions in class. We certainly don't have time to do that in a recap video. Okay, so moving on. Questions get tougher when you have to prove and without numbers. So with r and theta and so on. For example, this question, a lot of people find this question very tough. So that's something that you could go on and practice right now if you want. So that's the end of this chapter. Not a very long chapter. It has some very simple ideas. Going on to the last chunk of the syllabus, which is differentiation and integration. If you've studied differentiation, you will know it's the process of finding the gradient of the curve. It is represented with the notation dy over dx or f bar of x. When you plug in a particular value, what that value tells you is the gradient of the curve, or more precisely, the gradient of the tangent to the curve at the point A. A tangent is a line that touches the curve and passes. It may also go on and intersect the curve at a different point, but there are tangents at particular points, and those tangents could meet or whatever the case might be. So with differentiation, you need to know that how to sort of manipulate the powers, um, and this is just a basic manipulation of powers. Before I go on and review the rules, this is something that everybody needs to understand. It's differentiation by first principles. Again, you will never be asked to prove this on an exam, but you can be asked to interpret this. And how do you how do you interpret this? But this basic idea is that the gradient of a curve is basically the gradient of the tangent. So how do you obtain a tangent? If you want a gradient at this point, what you've said is let's find a point that's a little far away, but this tells you this, the gradient of this line will tell you what the gradient of the curve is, but it's not going to be very accurate. You could be more accurate by moving this point closer up together. So as you move closer and closer to P, your gradient of the chord or the line that you are making is becoming closer and closer to the gradient of the curve. So that's the idea of differentiation by first principles. It's an entire derivation that's not part of your syllabus, but you need to know how to interpret it. And one of the questions from this book illustrates this idea. So pause here, look at this question, solve it if you haven't already. Then you have these rules for differentiation. I have broken them up into more rules than are necessary, but that's how you sort of build it up for people who've never seen differentiation before. So when you have x power n, you bring it down. When you have ax power n, you again bring it down and sort of solve. Those are 4 rules. The differential of a constant is 0, and the differentiation of ax is a. When you have a function inside a bracket and you have a whole power, you can differentiate it by bringing the power down, and then by multiplying the differential of the bracket outside. A lot of people tend to forget this, and then things go wrong. So make sure that you remember this, that the differential of the bracket must come outside if there's an entire function inside a bracket. Now this causes sometimes confusion, so make sure that you're not confused and you know where to apply what. Some basic rules on differentiation, then some questions on again, if you're done add math, don't apply product rule or quotient rule and so on. That's not part of the AS syllabus. You need to just keep it basic. That's a derivative of function. Then this topic moves on to finding gradients of tangents and normals and so on. A normal is a line that's perpendicular to the tangent, and that question is going to come up in a bit. Tangents and normals are here. A normal is a line that's perpendicular to the tangent. So everything starts off with the tangent and then goes to the normal. You could be asked to do a backwards calculation as well, where I tell you the normal and then I ask you to calculate the point at which it was tangent. Moving on, some more complicated questions. You can look at this one and solve this if you haven't already. Again, looks like a very challenging question. Is very simple at the end. You can see the year and then go back and follow it if you want. Okay, that's the first part of differentiation. I generally break it up into 2 parts. The other one is called further differentiation. Further differentiation is basically a continuation of differentiation with more applications. The first application that I did for you was tangents and normals. The second application is increasing decreasing functions. Increasing function is simply when dy by dx, or the gradient of the curve, is positive. It's an increasing function. That means that the curve is going up. If the curve is going down, it's a decreasing function, and you have the gradient also being negative there. Okay, so I could ask you, where is it increasing, where is it decreasing? So it's a simple question on quadratic inequalities that you could solve. Then you can have it's still the same, most of it. Sometimes you may be asked to determine whether f is an increasing, decreasing, or neither. So what you do is you differentiate your function, you come up with an expression, and then try to analyze that expression. So you would often see squares here. So you see the denominator is a square, but the numerator is negative. So that means that the denominator is always positive and the numerator is always negative. Therefore, the entire function is, and therefore entire f bar of x is always negative, and therefore this is a decreasing function. Then before we go on to the next application, there's something called the second derivative or the double differential. What you do is once you've obtained dy by dx, you can differentiate it again. It might have different rules being applied to it. It doesn't matter. Just make sure that you know your algebra and you're doing the powers properly, and that should help you do the double differential. Why is the double differential useful? Why? Because we want to next calculate turning points or stationary points. Stationary points are points where dy by dx is equals to 0. A lot of these questions are about stationary points, and they sometimes lead to complicated algebra as well. They can have a lot of quadratics, they can have a lot of disguised equations as well, questions with radicals and so on. So make sure that you know your algebra when you are doing stationary points. Stationary points can either be maximum or minimum. Here are the rules that tell you whether they are maximum or minimum. That's where the double differential comes in important. Make sure you remember these two. When it's less than 0, it's a maximum point. When the double differential is greater than 0, it's a minimum point. That's something that you need to rote learn. It sort of is switched. A negative means maximum and a positive means minimum, but that's the rule. Okay, then all of these questions are there. This one was a relatively tough question since it doesn't have a number in it. It just has k repeatedly, so you have k throughout. Okay, then we have practical situations where you have maximum and minimum problems. A lot of people are confused by this. Again, mensuration is something that you need to know. All these formulas are assumed as part of your understanding. So if you need the mensuration formulas, go ahead and watch the mensuration video on my channel. You will understand all the formulas. I go over an entire handout where I have all the formulas written, so you can breeze through that and make sure that you know your formulas. Again, you will be asked to calculate stationary points. So dy by dx should be equals to 0, or whatever the function may be. Some real life questions from past papers. You can have more complicated questions. I was doing this question in class and we realized that an understanding of similar triangles is also necessary when you are doing AS math. So this question relies on your understanding of similar triangles. Then the last application is rate of change or chain rule, whatever you want to call it. There are various ways of doing chain rule questions. This is one way of doing it. How I do chain rule is I go on and first calculate my differential, whatever the question is about. If it's about area and radius, I calculate the dA over dr. If it's about volume and height, I go on and calculate dV over dr and so on, dV over dr or dV over dh and so on. Then what I say is that all these differentials can be broken down into rates of change. What I've done is simply I've taken the numerator and attached a dt with it, and I've taken the denominator and I've attached a dt with it. So that's what you need to do if you are calculating or doing the chain rule. Again, there are various ways of doing it. You see my differential here. I've taken dy by dx, just attached a dt with it, and just attached a dt with it, and I think that's the simplest way that I find it to sort of explain. Again, chain rules can be done in different ways. Your teacher might have told you differently, and it's perfectly fine to do it in whichever way you understand. There's no hard and fast rule to write a particular chain rule. This is sort of a difficult question. You should try and solve this if you haven't already. That brings us to the end of differentiation. Let's quickly go on to integration. Okay, integration doesn't have a definition on its own. It's just the reverse process of differentiation. Okay, so when you're trying to reverse the process, you do integration. that is finding the equation of the curve. You differentiated the equation of the curve to find the gradient. Now you're trying to go back from there. Again, rules are important. There's the rules written here for you. The most important rule here, which a lot of people mess up, is about functions with whole powers. So when you have such a case, remember that this third rule is only valid when f of x is a linear function, which means that inside the bracket you cannot have an x square or an x cube or so on and so on, or 1 over x for that matter. If you have those, you will have to sort of expand it first and then integrate. This rule is only applicable for linear functions, and you will see this in a couple of examples later on as well. All these examples are there. Whenever you are integrating, a plus c is necessary. If there are no limits, we'll talk about limits in a bit. That's the rule that I was talking about. You see both 1 minus 2x power 7, 1 minus 2x is a linear function, and 4x plus 9 is also a linear function. Okay, so the first application is finding the equation of the curve. That's a question. Pause here and do it if you want. It's another question from the specimen paper. Another question that I think involves a bit of disguised quadratic equations. Stationary points, this question sort of asks you to integrate twice. Why? Because they've given you d square y over dx square. That's something you need to integrate twice in order to reach the equation of the curve. Then there's something called the definite integral. The definite integral is basically an integral with limits. So you don't write a plus c, you have an upper limit and you have a lower limit. You apply the upper limit first and then the lower limit, and this value will give you out a number. Again, this is something that you can also verify on your calculator if you're getting the right answer or not. You can't simply use a calculator to do it. Then improper integrals, a lot of people actually skip this topic when they're doing their review. So remember that improper integrals is a part of the syllabus. Improper integral simply means that one of the limits is infinity. And what are the rules for infinity? Anything over 0 becomes infinite, and anything over infinity is basically equals to 0. So those are the two things that are important. I've seen more about the second thing, anything over infinity is 0. So whenever you have that, remember to write a 0. Don't get confused with other things in the question. Just go on and do the basic integration. When you come to limits, it's automatically going to make sense to you. Sometimes the answer can be infinite as well, but depends on what working you've done. And remember to sort of solve the powers first. You will need to do a bit of algebra in these questions before you can go on and apply the limits, because you have to make sure that you know when infinity is coming up as part of the denominator. So there's a question. You can look at this and you can see what I'm telling you. Okay, another question. That's the first part of integration. The second part of integration is not about just reversing the process of differentiation, but about the applications of integration as well itself. So what integration tells you is that if you don't really have dy by dx or anything, you can still integrate a particular equation of the curve, and when you integrate the equation of the curve and put limits into it, what you basically end up with is the area between the curve and the axis. So if you are putting in limits for x, you will end up with area between the curve and the x-axis. If we are putting in limits for y and integrating in terms of y, we have a dy at the end, then you are going to end up with the area between the curve and the y-axis. In this case, you have area below the x-axis, which means that the definite integral came out negative. You don't need to worry about that. You just need to change the sign at the end. Then another question to illustrate this idea. Then a past paper question. Solve this question. It's an interesting question. Gives you a basic idea of everything. Some more questions. Then it says area between curve and y-axis. That's something that I've already talked about. You have the equation in terms of y, and then you have a dy as well. If you have all of that, you'll have limits of y, not limits of x. You'll have limits of y, and you integrate on the y-axis, and that tells you the area between the curve and the y-axis. Then when the area is trapped between two curves, how I teach is I don't look at shapes, I don't look at other things. What I simply tell you is that if the area is trapped between two curves, you can simply do above minus below and have the limits. You need to know the equation of the line that's above, and you need to know the equation of the line that's below. The question that I have in front of you illustrates this idea very simply. It's a solid 8-mark question that you can see I haven't used a lot of space to do this. The integration is merely 3 lines. It's the equation of the line that I have focused on, or sort of the intersection points that I focused on, and this would give me a perfect 8 marks. There's no harm in doing this. Then some more questions can get a little complicated as well. Well, the last part of the syllabus is about integration and volumes. When you integrate the equation of a curve, you end up with the area between the curve and the axis. What you can simply do is you can put a square and then put a pi outside and follow the same process. In that case, it's going to give you the volume of the volume generated by rotating the curve between x equals to a and x equals to b. So it's about rotating something like that on the x-axis, and you're plugging in values for x. So that's giving you the volume between volume of the shape that's being created by the rotation. You can also have the same rotation on the y-axis. In that case, you'd need to have an equation in terms of y, square it, put a pi outside, put limits and so on, and you can end up with the same volume. So that's another question on rotation on the y-axis. Then the last basic part is, again, this is not a very tough question. It does say volume of the cone at the end, but if you see my solution in the videos that I've solved, I solved this question without bothering about the volume of a cone. I just use the ideas of simply squaring, and then putting in limits helps me solve the question. Sometimes the area is trapped between two curves or two lines and so on, two curves or one line and a curve and so on. Again, I use the same idea that I've used for area as well. I use above minus below, but this time I go like above squared and below squared. So what I'm doing is I'm finding a larger volume, and then I'm subtracting a smaller volume from that larger volume in order to get my desired volume. Why? Because when you rotate this shaded area around the x-axis or the y-axis like that, it's going to create a hollow shape. When it creates a hollow shape, the simple idea that you've learned in O level as well is that you need to subtract two volumes in order to get a hollow shape. Okay, so that is what I do. I do above squared minus below squared. You can pause a bit before and then look at the solution here. You can see I've done a 9-mark question in pretty much 5 lines there. So it's absolutely fine, doesn't matter, as long as you have all the working correct and you've shown me all the working that's necessary. That brings us to I think the end of the syllabus. There is nothing more left. I hope this revision was, this recap basically was comprehensive, and if you're watching this on the last day, the other thing that I would recommend is that if you've practiced past papers and you've asked your teachers some problems, or you've asked your friends some problems, please go back and revise those questions, and don't try to solve new past papers right now. Don't try to solve questions for other people. It's not a wise idea to put yourself under pressure on the last day, and you should be focusing on yourself and trying to stay calm. Don't try to rehearse things in your head. It sort of messes up your memory. Just keep calm. If you've done enough practice and you remember all the ideas that I did in the recap, you should be pretty much fine doing the paper. If you watched this video, please make sure to like and subscribe. Good luck with your exam. Thank you.